Hello everybody, welcome to the OpenValue Meetup. My name is Roy Wasse, I'm your host for tonight. We have two really cool talks for you tonight from two innovative startups. First up is the Stream Machine. They have a really nice platform for GDPR and real-time. And we have a talk from Deploy. We're going to talk about explainable AI and MLOps. Really awesome subjects, I think. So first up is the Stream Machine. Please take it away, guys.
Hey, welcome. Thanks for joining our talk. We're engineers from Stream Machine, which is a company and a platform. And the goal of what we're doing is to provide fast, privacy-secured customer data, event data that you can actually use. So in this talk, we're going to give you a brief overview of what Stream Machine is and what benefits it can offer for event processing. And we're going to demo how you interact as a developer with the Stream Machine platform. So our goal, the goal of the company, is to provide a platform for event processing where the privacy issues that are very tightly coupled to event processing, customer data processing, are the concerns about that are taken care of by the Stream Machine platform. And this talk we're going to show you what those principles are that we're doing. Who are we? Well, I'm Bart van Deenen. I'm the first engineer of Stream Machine, not necessarily the lead engineer. I was previously at, for instance, bol.com at KPN, but also I originally come from an aerospace background, working at ESA. So I sort of went from what we call hard real-time processing, which is microsecond latency and less, to currently soft real-time, which is milliseconds. Stream Machine is still plenty fast, so I'm okay with that. I love Erlang programming and rock climbing and programming in general. So that's my background. Let me introduce you, my colleague.
Hi all, my name is Robin Trietsch. I'm a software engineer at OpenValue, currently working for Stream Machine. I previously worked at bol.com, where I also met Bart. We briefly worked together, but now we're working together for a longer period. About me, I'm a big fan of Kotlin, and well, I mostly use JVM technologies and data engineering, the data engineering stack, such as Kafka, which Stream Machine is also built on. I'll give the word back to Bart.
All right. So, Stream Machine was founded, the company was founded, and the ideas of the platform are built to solve the problems that teams have, that data teams in companies have, that struggle with balancing privacy, both on a moral level and on a legal level. The GDPR is very, very important in this level. And so we want to, companies struggle with finding the balance between innovation and privacy, and which often amounts to a data scientist, a data science team receives data, and the data scientists think, can I use this for the purpose that I have? Am I even allowed to see these data? Can I store it? What if there's a right to be forgotten request? How do we get rid of this data? All those questions are very real in a company of any scale. If you look at, for instance, the GDPR, it says that data have to be acquired for a specific purpose. You can't just acquire everything and decide on a purpose afterwards. So currently, most companies handle this or don't handle it, but leave it up to the data science teams, and they are often struggling with this. Stream Machine aims to solve this. So companies are also having this issue at the moment where they sort of have to almost make a choice. Do I go fast and actually get value out of the data and typically not be actually legal with the data, not be GDPR compliant? Or do I go very slow and make sure that I am GDPR compliant? That's almost a catch-22. It's either one or the other. We think we have a pretty good solution for this. Our solution indicates that every event that Stream Machine receives, that the customer application creates, gets assigned consent levels, event level per event. So it can change for every event. Customers can change their mind continuously. And all the personally identifiable information inside an event is encrypted by Stream Machine with a rotating key. We can go in details later. Which means that after the encryption, the event is privacy safe. It no longer contains PII, personally identifiable information. So once Stream Machine has done the primary processing, the outgoing event stream is fully GDPR compliant. It can be used by anyone in the company with no hassles whatsoever. For more personalized activities, for instance, something like personalized marketing, you actually need consent levels from the client, from the customer, saying, I'm okay with personalized marketing. So this would, on event level, the PII data would still be encrypted, but those teams in a company that require those personalized marketing data, they would actually receive decrypted data where those fields are actually available for them. So a personalized marketing team would just subscribe to the event stream, which is okay for personalized marketing, and they would receive exactly what they have a right to. So problem solved there. The fact that we encrypt from start also means that if you decide that you want to store long-term data, you can just store the encrypted data, and if a right to be forgotten request comes along, you only have to throw away the encryption key, which might be a lot cheaper for if you have large amounts of storage, instead of actually changing the long-term storage data. So that's what Stream Machine offers as benefits. We take care of the technical part of streaming data. We are very experienced with the data engineering that is applicable, and privacy by design, not as an afterthought. And that's very important, we think. Okay, up to Robin.
All right, thank you, Bart. What Stream Machine offers is highly available event streams at any scale. This is done using the following architecture. This, of course, is a simplification of the architecture, but the ideas are still valid. So what we see here is several applications sending events to our gateway. That's our entry point. And what the gateway does at first is validating these events against the validation rules that apply to the schema that is linked to these events. For validation rules, you can think of, for example, regex rules. Certain fields should match a certain regex pattern, and if they don't match, the gateway will reject them. So when the validations have passed, the next step is to encrypt the personal identifiable information fields. For each personal identifiable information field, a different consent level can be linked to that. But all fields that are PII will be encrypted. These encrypted events eventually end up in the encrypted data stream, which is internally represented as a Kafka topic. What you also see in the middle are several decrypted data streams. And these decrypted data streams are optional. They are created upon request of a user of Stream Machine. And the large benefit here is that you can actually partially decrypt the events of the encrypted stream. So if you're interested in all events that have consent level 1, for example, you can request that these events or actually the fields that match consent level 1 are decrypted. This decryption can either take place in the infrastructure of Stream Machine or can be done at the user's infrastructure. What we also offer is an egress interface, and this egress interface is merely meant as a debugging interface and is, well, it uses WebSockets and server-sent events to, well, proxy all messages from a certain stream to a developer to easily develop your application that's using Stream Machine. Next up is the actual demo. So please hope that the demo gods are with us this time. We would like to show three things. The first thing is a sign up and a walkthrough of the schema that we will be using through this entire demo. The second one is a fictional web shop. So that more or less represents a real life use case which where you can use Stream Machine for. And the third part is the batch exports, so exporting large amounts of data from Stream Machine into, for example, S3 buckets or Google Cloud Storage buckets. So the first part that I like to show is our main website. You can read more on Stream Machine over here. Well, what you can also do is sign up for our alpha. If you go to our sign up flow, then everybody has seen such a sign up flow. You can follow the instructions and create an account, verify your email address, and next you can start creating a stream and actually send and receive data using that stream. I already took the liberty of setting up an account, so let me log in over here. Whenever you created an account and verified your email address, you'll be presented with this. This is our portal. And the first thing you can do is create a stream. But before I dive into how to create a stream, let me quickly go to the schemas. So at the moment, there is only one schema available. As I said, we're in alpha, but more schemas will be added in the future. A schema consists out of two parts. The first part is actually shown here at the bottom, is the serialization schema, which can be of different types. Here we have Avro, but at the moment we also support JSON schema. We also have the ambition to support more types in the future. I won't dive into the details over here. This is an Avro representation of a schema. That's just how the payload is serialized, and that's how the gateway knows what kind of data is actually being sent. The top part that you see over here is the actual schema definition. This is what we call the schema definition, and it's a meta schema that describes certain things about the payload. The first thing is the schema reference, so the type of schema and the actual reference to the schema. The second thing are the validations. So the validations here are regex rules, and we see that the field customer ID, it basically says here it should not be empty. And for the URL, it should match the pattern here for a URL. The key field of the schema definition says which field in the serialization schema is responsible for tying events together. So which field links events in a sequence together. In this case, that's the producer session ID field. And the last part are the PII fields, and that says which field have which consent level. So here we say that customer ID has consent level 0, and producer session ID has consent level 1. The numbers over here are just a representation. You can tie any label to it, and in the demo we also have tied labels to them and do a translation there. So now that we know the schema, let's move along to our simple web shop. So well, this web shop, as you can see, it exists of 20 products. So you can't buy a lot over here, but it does the job. So there are enough products to actually scroll. You can click on a product, which will show a detail page for the product, and you can add them to your cart. So quite basic, but it does the job for this example. What we also have in the bottom left is a very simple cookie consent. And at the moment, I didn't select any cookie consent. And we also have this text box over here, which represents our customer ID. So we can fill out the customer ID here. That's because we don't have a login flow implemented here. But for the sake of the demo, I'll just fill out here OpenValue Meetup. We implemented several events that are being sent to capture the behavior of the customer that is visiting this web shop. So whenever I click on a product, this will trigger an event. Whenever I add it to cart, that will trigger an event as well. Let me show you what happens when I actually when I listen to these events through the egress. So I have this function over here. Let me quickly show you what it does. So what it does, it consists out of two parts. So the first thing is we authenticate to our authentication endpoint, where we present our billing ID, our client ID, and our client secret. So these credentials, you receive them when you go to the portal and create a stream. Then you'll present it with these credentials. You have to store them. And I already did that for this demo, and I've got them over here. For the ones that see these credentials, don't worry, we'll remove the stream after this meetup.
15 minutes.
So the next part is a WebSocket command line interface. We'll pass along the ID token that we receive from our authentication endpoint, and we connect to our WebSocket, and we pass along a query parameter so that we actually get the data back as JSON, because then we can pass it to JQ. I want to reshape the events a little bit, because otherwise it's too much info to show on this screen. So let me actually run this. So it connected to WebSocket over here. So if I click on a model, then you see product 2, open model. Consent levels is empty over here, which is correct because I didn't fill out the cookie consent. The customer here, well, if you remember from the schema, it had PI consent level 0. So it means it's encrypted, because actually what I'm doing now is reading the fully encrypted stream. That's why you also see that this data is encrypted. For the session, I abbreviated it here. This is the producer session ID. That's also encrypted, but that's of a different consent level. So of course, I can close the model, and then it also shows. So let me also start the other stream. So we have two output streams that we also want to read: consent level 0 decrypted and consent level 0 and 1 decrypted. And they are increasing in my screen over here. So let me start them. And well, if I click it, click the same product, I don't see anything happening over here. Well, why is that? That's because I didn't provide any consent over here. So let me switch to the analytical level. What I expect if events are being sent now, I expect events to appear over here. And as you can see, the event appeared over here. So it's the same event, but actually the customer here is decrypted. As you can read, it's broken up into a new line, but it says OpenValue Meetup. It's the customer ID that I fill out in my browser over here. And as you can see here, the consent level also changed here. So the previous event had no consent levels, and now we have consent level 0 here. And I can repeat the same trick, of course, with marketing. There we go. So it was a startup hiccup. So that's why we say that this is a debugging interface. So it's only meant for testing purposes like these. So as you can see here, the consent level changed again. It changed from only 0 to 0 and 1. And if we look at the bottom stream, we see that the session ID is also decrypted, whereas the session ID was still encrypted in the second stream. So enough about that. Let me show you what happens when we go to the network tab. So if I actually click on a product, it calls an endpoint in our backend. Well, why is that? That's because of two reasons. The first thing is this way you can actually keep your secrets, your client secrets of your streams safe, because they are in your backend and not in your front end. And the second thing is that we offer drivers for backend applications, and it's often easier to change backend applications than it is to change front-end applications. So let me also show that quickly in IntelliJ. Let me switch to presentation mode. So the endpoint that was just called was the model endpoint. Actually, what we do is we receive a model product event, which basically consists of two strings, the product ID and the action that was done on this product. Well, we want to send an event, and this is just a convenience method. But in the end, it creates a clickstream event with this data. So as you can see here, what you see over here is the Java class representation of this Avro schema. And we actually just build the events over here using these this Java class. Whenever we create an event, after that we send it with the Stream Machine client, which is our Java driver, and that's how it ends up at the gateway, and then it's validated. Let me quickly show you one more thing. You already briefly saw it, I think. So to show the power of Stream Machine, we implemented a simple JavaScript over here. Whenever you start scrolling, that you see that products enter and exit viewport, and this sends a lot of events. But this exactly is what Stream Machine is made for. These amounts of data at this granularity, and it's just up to your own imagination of what you want to do with this. All right, that's it for me. I'll give the word to Bart.
Okay. The last bit of the demo, it's a not yet released feature, but one of the things we will provide is that when you define a stream, you can just start a batch exporter, which will export all the events from your stream to a cloud bucket. Think AWS S3, or in this case, what I will demo is a Google Cloud bucket. And what you will get in the bucket are batched groups of events per time slot, in this example, per 2 minutes, of JSON lines, which is a very common format for data scientists, obviously. And the batch exporter is made in such a way that, that you will get exactly the events that came in, that were accepted by the stream machine, no more, no less. You will get them all, and you will get no duplicates. So it's idempotent writing with correct Kafka handling and such. And so this is a very small sample set. We actually built it, I think, yesterday. Unfortunately, not from Robin's demo, but from a load generator test that we have. And let me see, where is it? Ah, there it is. Oh, let me just get a bit bigger. So one line of data will be something like what you see here. So it's a JSON representation of the Avro schema. So this is what the bucket you saw consists of many lines, multiple files of many lines of these. And we actually, we just this morning created an interface to BigQuery, which is a Google SQL interface to buckets. Amazon has the same, I forgot the name. Athena. So Athena plus Amazon S3 is pretty much the same thing. And let me see. So here, it's extremely easy to hook up these two. So this is a data set. This is the one that I did this morning, but I'll show you how this works. You say, add a new table. The mouse is a bit shitty. Google Cloud Storage. Let me find first of all, it's not Avro, it's JSON line. Oh, I must have to look at my screen, that's easier. And you just, I don't pick one file, I want them all. Star. Okay, let me see. Batch exporter, I'll give it a name. OpenValue. I say auto detect. I actually say that the table is the original data. Let me see, JSON, okay. There we go. Go to table, query table. Now let's take all of them. And there we are. How do I get this bigger? Oh, there it is. So here's a SQL query for your event data. I have a few saved queries here. Project queries, for instance, this is a count for a group by the different A/B tests that we have in the events. And there it is. Well, I said it was from a load generator, so they're all pretty much identical. So I have a couple of events for A, for none, and for A and B. So it's very easy for your data scientists to work with these data at a batch level. This is on a closed roadmap. It will be done in a few weeks. That is live for customers. Just click, and you have your bucket output. This is the end of our demo. So the demo time. Well, the demo gods were with us. Present. So that's not so bad. If you want to try more, Stream Machine IO shows you the steps. We have this, we have live, we have a blog post, we have documentation. It's still early, but it's not too early to use. Any questions?
Okay. Thank you very much, Bart and Robin. That was really an amazing talk, and you showed quite a lot last 30 minutes. A great working demo. And it's especially impressive if you know that you've been working on this basically with 2 developers together with both co-founders for just this year. Actually, I think you started somewhere around June or July, and that you already have come this far. Really, really amazing. So there is actually a question in the chat I would like to relay. Frank is asking, hi, if we were decrypting on our own hardware, why would we need partially decrypted topics? Can you maybe clarify that a bit, please? Bart or Robin, please.
Why would you need it?
Yeah, so yeah, I think you maybe
Partially decrypted, that's actually, that's an easy answer, because GDPR says that you should collect data for a certain purpose. And if the data was collected for another purpose, in this case another consent level, then you're not allowed to look at that. So we provide a mechanism that the people receiving the data, the teams that receive the data, will only get the data they have a right to. That was consented by the customer. So that's solved. And of course you could, we pretty much explained how our system works. You could build it yourself, obviously. But we also solve the operational issues of working with this kind of stuff at scale. Yeah, we're already running it at 10,000 requests per second. So we handle both the privacy and we handle the privacy aspect, we handle the data quality aspect, is a very important one, which almost glossed over it. But we can apply complex rules to the content of your data. And we handle streaming data processing at scale with fault tolerance and such built in. So I think we'll eventually be cheaper than a do-it-yourself solution.
Well, I'm pretty much convinced that it will be cheaper. If I know the amount of research that went into this system and the problems you solved, the technical challenges and how you overcame them for sure. Thanks very much also for the explanation. And GDPR is of course something that we're just realizing what the real impact is, and a lot of companies out there still need to do a lot of work before I think they're truly compliant. And I think Stream Machine can be potentially a really good fit for a lot of organizations.
I think this company was founded from a lot of real knowledge on what GDPR means for real stream processing. So the legal issues are sort of at the core of the design of this thing.
Okay, well, Frank says, okay, thanks for the question. And Robin wants to add something, please.
So, I think the question was more aimed at the topics. So why would you need the decrypted topics? If we run the decryption process in our infrastructure, then we need those decrypted topics. Because that's how we keep track of the decrypted streams. But if you would run it on your own hardware, well, then you're responsible of what you are going to do with that.
I see. Yeah, that's a really good addition. Thank you very much for that, Robin. So we came with this answer to the end of the Q&A of the first talk. We're going to have a short break now. We're going to continue at 1940. That's in 7 minutes. So you can have yourself a cup of coffee or do something else in the meantime, and hope to see you back in a few minutes. Thank you.
Hi everybody, welcome back. I'm again your host for the evening, Roy Wasse, and I hope you had a really exciting first talk. I know I liked it a lot, but we have another really cool talk about a subject that I think is one of the hottest right now in IT. It's about explainable AI. It's maybe one of the holy grails currently, and ML ops, also really interesting subject. How can you do proper ML ops? We have somebody from Deploy here tonight. It's Tim Kleinloog. He is a technical director and also co-founder of Deploy, and he's going to tell you all about their solution. Take it away, Tim.
Thanks, Roy. Yeah, nice to be talking here tonight. So I'm Tim Kleinloog. I'm technical director of Deploy, and last years I've been working as a machine learning engineer and consultant, and worked for several companies, larger companies and also smaller scale-up companies. And actually, yeah, I experienced that it is very important to when going to a production phase with machine learning, that those machine learning models should be that there should be a certain interaction with those machine learning models from a human side. So those models aren't self-explanatory, so there should be some way to control them, make them manageable, accountable, and explainable at the end. And that's actually why I started Deploy together with 3 co-founders. And tonight I will spend some time talking to you guys about why building machine learning engines is actually a hard problem. So maybe many of you have tried to experiment with some way of building machine learning, experimenting with machine learning, but actually building a production-ready system is pretty hard. Then the need for explainability. So explainability is a whole research topic on its own, and it's I believe at least that it's really important for the reason that I just told you, that machine learning includes some form of explainability. Also, it has a relation to building machine learning engines. So it's not only an engineer who's going to build a machine learning engine. There are a lot of stakeholders involved. That adds a lot of complexity. Explainability is one of the solutions there. And maybe most important for you guys is just a hands-on example that you can try at home after the talk or during the talk, depending on how fast you are. Showing you the whole end-to-end life cycle using KF Serving. So KF Serving is an open source project. I think it's backed by Google, and with Deploy we follow the logic that KF Serving is laying out. So actually really interesting concepts there that I will show you from the end to end. So a lot of things to do in a short time. So let's get through it. First topic. So why productionizing machine learning is actually a hard problem. I actually saw 2 things, or at least I divided them into different areas. The first one is actually that machine learning systems are technically really complex systems to deploy and maintain. I recently talked to an architect who even questioned whether a machine learning deployment could be seen as a stable software on its own. So actually a really interesting thing to think about. And then on the other hand, there is the whole process that is currently still being actively discussed in research as well as in practice. But I will give you some insights in how I think that a good machine learning process should look like, who are the main stakeholders, and why there's a need for MLOps software. So first, the first topic. So this picture may be in some form be familiar to you. So it's actually from based on a well-known paper that Google published, and actually the ML code that's also often being developed by non-software engineers is just a really small portion of the whole system. So there's a really large part of, also related to the previous talk, the whole data collection, validation, verification process. There's a large serving infrastructure. There is a need for monitoring. There's a whole configuration and version control. It's also the technical depth here is really a point of interest. So yeah, to solve this is not an easy task. And even if we think about the next step, so this paper is already from a few years ago, if we're going to control machine learning, then maybe it's getting even more complex. So all the tools and things that are being developed in order to control the machine learning code is extensive. So it's actually quite complex to make your own solution in this whole space. And then second thing is the whole MLOps process. So a slide with a lot of information. So maybe you've seen like the phases in the loop before. So in DevOps provides some practices, of course, for machine learning that we can use. So of course, many of you are familiar with the infinity loop. But with machine learning, often there is a phase added before that, and that's actually the exploration phase, where also after the exploration phase, many good initiatives die in the laptop's graveyard, so it's never going to arrive at a development or operations phase. And also the stakeholders, so maybe some of you are even involved in those processes. There is, of course, in machine learning, if it's not like a business problem that we're trying to solve, that's quite a rare case. So normally there's always a case where we can add value by applying machine learning. Of course, we want to try to let the data scientist be as autonomous in the whole process as possible. So there is the most statistical knowledge about the modeling procedures, which algorithms to use, the cooperation with the business again to define evaluation metrics. But also related to the previous talk, there's not only like the business and the data scientists who are like celebrating their freedom in modeling and solving problems. There's also like a whole legal and ethical framework where we are behaving. It's actually the whole ethical and privacy framework is a bit behind the whole machine learning movement. So it's actually good to incorporate that in your whole MLOps process, because eventually it's going to be there and you have to answer to the questions that are being asked. So actually, to do the first part right, there are a lot of tools being developed. So there's just a unified way of data and modeling and experimenting, comparing your runs, a whole lot of space. So actually, in this talk, I'm mostly interested in going to demo the second part. So that's more the unified way of deploying your models to a production state. And there's also the integration part with your business application that's going to consume the results of the machine learning. And there's also really a need to control an algorithm when it's actually producing results in a production setting. So for that, explainability is one of the solutions. So let's dive a bit more into that. So the need for explainability. So as you've seen, the many stakeholders, they are not all statistical experts or really technical people. So understanding what a machine learning system is doing is of keen importance for the success of the system. So it can be technically perfect, the model can be a genius, but eventually it's only going to be successful if like the involvement of the different people are there. So from a business point of view, there needs to be, at least I believe there needs to be some involvement in the automated decision making. So if it's not validated by an expert, there's no trust in the system, it's doomed to fail. Then there's the data scientist who can also use explainability for mostly sanity checks. That's actually, I think, currently the way it's used. So there are already, of course, data scientists using this, especially for just sanity checking their outcomes. Especially with really complicated machine learning models, you can always use explainability sanity check this. And eventually, this is still, of course, something that's a next step again, is to involve like compliancy to check the fairness of this decision. So really making sure the decisions are fair is still quite hard, and that's mainly because of the reason that you see on the slide as well. Explainability is again a statistical method, so it's not going to underpin any causality. And if you're speaking about explanations, it's actually easy to make that mistake. That this is still like a sort of using algorithms to validate algorithms. So that's also one of the main reasons why this is in practice. It's still quite hesitant to use these methods, but it's certainly potential. So how to approach this then? What I would say, thoughtful deployment. So if you're going to deploy machine learning, there are a lot of possibilities there, and there are also a lot of nice algorithms and libraries being developed. So why not just use it, but make sure to keep into account the following things that I list down here. So of course the context is really, really important. So make sure to evaluate on the right metrics, understand the limitations, so different algorithms that are being used. In the demo that I will show you, I'm going to use anchors. So all of these algorithms have their pros and cons, so make sure you know the limitations. Also know how to deal with uncertainty. So as well, machine learning and explainers are going to fail. There's always an uncertainty, so that uncertainty can be really low, but it's not going to underpin any causality. Also understand the interactions from the people that are going to use those explanations, and make sure to understand the expected change in behavior. So below I made a drawing of how such a process could look and who are the stakeholders involved. So actually the picture that you see and the small images are based on a real life case that they actually participated in. So it's for handling airline claims. So according to some laws in Europe, you are able to get your money back if your flight is delayed. So what's being done is on the website, they're customers filling out a form. The company is collecting the data, and there are a lot of actually legal experts assessing all those claims, which you can imagine. In Corona time, this is a little bit less, but before in the summer times, they needed to scale their legal experts, and that's actually quite hard to do. So in order to do that, we applied machine learning there. And but in order to build the trust of those experts, we used explainability to involve them in the whole process. Not by telling them what to do, but actually involving them in the process, so giving them an advice on whether a claim should be eligible for a refund, and actually collecting their feedback, building a whole feedback loop to again improve the whole system again. So that's actually one way to apply explainability in practice. But of course, we didn't involve them immediately because that would change their behavior. We first did some shadow runs in order to make sure that the model is again good enough to involve people there. Then I'm going to move to the demo. So a lot to explain here as well. So this is actually the setup that I'm going to show you today and to demo with you, and also give you the ability to try this yourself. So actually there's a link in the slides as well to a GitHub repo where you can reproduce what I'm going to show you today. So actually we're going to start from a situation where we have already trained a model, and we're going to upload that to an S3 storage. So that can be on Google, on Amazon, or on Azure, whatever you like. We're going to use our local machine as our compute. So I'm going to use Kind for that. That's actually a local Kubernetes cluster. And on top of that Kubernetes cluster, I'm actually installing Istio as a service mesh and Knative for using its serverless capabilities. It's especially useful when you're going to run really big models with large GPUs that you want to save some costs. And KF serving is actually a custom resource definition on top of Knative that's able to, based with a certain abstraction level, use actually the most well-known machine learning frameworks that are there. So as a machine learning model, I'm going to use a scikit-learn model. Maybe you've used that yourselves as well. And actually there's also there's also a first explainability library, Alibi, and I'm going to use Alibi to deploy the anchor explainer. And together I'm going to make the explainable machine learning deployment. So eventually we're able to consume predictions and explainers as well. So pretty exciting stuff. All right. So this is the repo that you will be able to reproduce it. For now, I'm going to, I already did some preparations. So I already configured a Kubernetes cluster. I'm using Lens actually to monitor what's going on here. So there are also in the README there are instructions to install this on your local computer. So as you can see, I installed Istio here on this service mesh. I also installed all the dependencies that are needed there, and I also made a new namespace that I called Explainable Machine Learning Engine Demo, which is currently empty. So this is actually the namespace where I'm going to deploy my my explainable machine learning engine. Yeah, so that's what I already prepared. Otherwise, we're going to have a really long demo. Often making your first machine learning deployments also starts with thinking out some kind of infrastructure where you're going to deploy it. In this case, it's quite so make sure in the instructions is of course for demo purpose. So if you really want to configure this for your production environment, it's going to take a lot more effort to configure this right. But for now, also KF Serving has a nice way, a nice hack as they call it in their folder to do a quick install of KF Serving on your local cluster. And that actually gives the same result as I'm going to use today. So again, I already created my namespace, which I'm going to use for my deployments. And I'm using Python as my modeling language here, so make sure to use the environment that I provided here, using the requirements.txt. And then, okay, the modeling can start. So I'm not going to go into too much detail here. So it's quite a straightforward ML 101. So maybe to give some context about the case here. So this is a well-known census data set where we're going to predict whether someone is going to earn over $50,000. So that's actually what we're training our model for. And that's already quite an interesting case because in this data set are quite some interesting variables that are, yeah, we could have some debate about whether it's ethical to use those variables to predict the outcome. Especially, you can imagine if those variables are going to be used to determine whether you're going to have a mortgage or not. So interesting case to apply explainability. So this actually I already did for you guys. So I'm not going to explain too much. So I'm splitting my data set and doing some preparation. I'm training a random forest model. That's actually quite a black box model. So it's not really explainable anymore by itself. This is maybe a new step for some of you guys. So based on the training set that I train my model on, I also can fit an explainer. So in this case, I'm going to fit the anchor explainer that I just said is part of an alibi. That's one of the first explainability packages that is provided there. And that's going to give me the possibility to do some post hoc explanation. So based on the results that I receive, it's going to look for spaces in the data where there's a unique set of variables that's going to explain the result that I'm producing based on the input data that I'm feeding it. So actually quite interesting. So it has nothing to do with the machine learning model that I'm using for the prediction. It's really doing a post hoc explanation in order to validate it, and also can provide me with some metrics in order to assess whether I'm making some assumptions that I can or cannot do. So Anchor is just one of the many algorithms that are being there. They're actively, I think there are many papers appearing every month, so it's a really hot topic as mentioned already. So after fitting the explainer, this is the end of actually the exploration phase. So the only thing that I'm going to need to do is to export my model files in order to save those artifacts to, in this case, I'm going to use the Google Cloud Storage for that. So for sklearn, we are using a joblib extension, and for the explainer, we're using a Del extension. That's actually an exporting format that can include like Python objects. And as a next step, I'm going to export it to my Google Cloud storage. So I actually already did that for you guys. So you can actually see that I have my deploy storage, and here's my model. Actually did that today. So this is my joblib model, and actually my explainer is here as well. Yep. So in KF serving, I can again point to those artifacts in my artifact storage, as you've seen here. So actually in the artifact storage, where I'm going to which I'm going to use to deploy my machine learning engine. So that about the training part is really fast, but if you have any, so make sure to do this in a real life setting to spend some more time on the modeling process and do it thoughtfully. This can be a really long process. Then maybe most interesting part is the deployment to KF serving. So now I'm actually in the next step of the experimentation phase. This is something that I'm going to deploy. So KF serving is a nice Python client. It's still in an alpha stage as well, so we're pretty early with it as well, but it's actually working quite well. So first of all, I'm going to load my Kubernetes client in order to talk with my local Kubernetes cluster. And then I'm going to use the KF serving client that I installed with my requirements, the TXT. And KF serving has a lot of classes which I'm going to need in order to deploy my model. So I'm going to load those in as well. And then I'm going to define some constants. So the API version that I'm using, the namespace that I'm going to deploy my machine learning engine in. There's a link to my Google Cloud storage. And because I use the credentials to make sure that not everyone can clone my explainer and my model, I also can provide my service account here. So let's load that in. And then there's this step where I'm going to attach the credentials that I created to my namespace. So also prepared that already. So if you're going to look in Lens on the secret side, then I see that on the namespace Explainable ML engine, there's already the secrets. So if everything's going well, then I should be able to communicate with Google Cloud Storage from my local deployment, starting with the initialization of my KF serving client. And after that, I'm going to define what I actually am going to deploy. So KF serving is using a default endpoint spec for that. So the default endpoint spec is actually the default model that I'm going to explain. So KF serving also has the ability to deploy a canary endpoint as well, in order if you want to, for example, safely switch to another version of your model. And in the endpoint spec, I'm going to note to provide like the service account name. I'm also going to so since KF serving is like an abstraction layer on top of many of the frameworks, I need to point to the SK Learning spec that they are providing. Again, point to the URL. I can specify a version that I'm using. And this is also interesting, so based on the type of model that you're using, you can also specify the number of resources that you're needing. And if you want to go full serverless, you can also scale down to a minimum number of replicas of 0. So in that case, if you're not going to use you're not going to call it actively, it's going to scale down to 0 pods, and you're not going to use any resources. Then actually for the explainer, I'm going to do the same. So again, if we look at the picture, the single deployment also contains an explainer. And for the explainer, I'm going to use the artifact of the alibi explainer spec. I'm going to point to the storage URI, specify the tabular. I'm going to reserve somewhat more resources for it, because explainers still need somewhat more resources than the standard models. And if I'm going to do that, then this can be input for my infra service object. Again, in this space I can add some metadata. So I'm going to call it income model, deploy it to the namespace, and here I add the information I just made in the default endpoint spec. I can immediately also add a canary deployment here. I'm not going to do that right now. And also assign a certain percentage of the traffic to the canary deployment. It's interesting to do, especially if you want to go to a new version of your model in quite a safe way. So again, I'm going to initiate that. So actually, the only thing I have to do is to call the create method, and I get some feedback back from here. But most interestingly is if I go to the pods, you actually see that my explainer and my predictor are starting up. And this is like the live deployment of our machine learning model in our explainer. So I can also call, it's actually not ready yet. So calling the inference services, and actually now still not, and now I think we should be ready. Yes, so it's actually ready. So as you can see, there is an internal endpoint connected to our deployment. So it's ready. It's going to receive 100% of the traffic because we didn't supply a canary deployment. And what this means is that we actually can test it out. So that's cool. So I can also do that in Python again. So for the model, I use the income model, and use this namespace. I use the host, which is actually a combination of a namespace and the model name. And I'm using the ingress host by port forwarding it. So actually the only thing I have to do to test this out locally is to port forward the ingress gateway that also Istio is providing. So that's happening right now. Specifying our inference service. So as you saw in the picture here as well, we have an predict and an explain endpoint that's actually using the same API endpoint. And to make this more real, I also added an API that's going to provide us with some sample data. That's actually the same data set that I used to train the model on. So it's actually a really simple, fast API to provide us with some data. And now I can like call random people that we're going to make prediction for. So in this case, I have a person with the age of 53, an unknown working class. It's a white female, and yeah, somewhat more information. And actually, in order to send it to my model, I'm going to transform it to actually an API specification for machine learning that TensorFlow developed, which we're using, and making a request. And I do this on the explanation endpoint, so that's also good. So I'm getting back quite a long JSON file with a lot of information. And to make it more concrete, I filtered that a bit. So actually we're getting a negative prediction, so that means that in this case the income is not going to be above 50,000 euros of dollars. And the explanation for this that the anchor provided is that the reason that it's thinking it's negative is actually that this person is separated and that there is an unknown working class. And it's actually pretty sure about this because the precision is above 95%. And this is actually telling us a bit about the coverage in the data set that it's using it for. So it gives us some feeling about the certainty of the explainer. So that's actually our real end-to-end deployment. So it's running in prediction on a Kubernetes cluster in a serverless way, providing us with explanations. I can repeat it once more time, so for a different person, to give you somewhat more feeling. So this is actually a person 26, never married, and made some capital gains. and again, requesting the model, giving us again a negative prediction, making the prediction based on the Marriott and the age. So it gives you some feeling about why this is actually happening. And this can be used with business experts again to validate whether your model is actually properly functioning. So yeah, pretty cool. So I would certainly encourage you to do this, try this yourself. Yeah, thanks for your attention. So feel free to email me for any questions that you have. If you're interested in deploy, so maybe I showed you also that deploying those kind of models is quite tricky as well. So of course, you feel free to contact us for a demo how we are solving this problem of making explainable machine learning engines, and also if you like to work with us to accelerate the whole process of deploying, then yeah, feel free to contact me again. So yeah, thanks for your attention.
Okay, thank you very much. Loud applause here in the studio for you. So, well, I must say, watching this talk, I'm not only impressed with what deploy can do, I'm also very much impressed with your personal engineering skills. I mean, you're using a bunch of technologies, cloud, Kubernetes, the infrastructure, well, Python, of course, machine learning stuff, etc., etc. It's so much. So really awesome to see how you tied it all together to make it all work. I guess you explained quite well. We do have a question in the chat just coming in, and that's from Robin, I guess, judging by his last name. It's not correct, he's nodding no, and that's not the previous speaker, but it's from Triso. He's asking, awesome to learn what you're building. How would I offer my customers this explainability? Is that something you envision? I can imagine wrapping it in my own API.
Yeah, so providing it to your customers is actually what I see as really an end state. So of course, you can expose it, also maybe related to the GDPR discussion there. There is also, in the GDPR, there's a right for an explanation of automated decision making. So, of course, if you're going to use automated ways to assess and make certain automated predictions for customers, then of course, if you get a question and you're using these kind of technologies, you're always able to provide an explanation in normal human language. But yeah, I think maybe at this point in time, explainability, I'm doubting if it's yeah, you should really think how to apply it, in what use case, in what context, because you really have to make sure that your customers understand that the explanations are not causal. So that's, I think, the main reason why there's a little hesitation to use this for customers.
So one follow-up question then, because one of the issues with machine learning is that there can be a bias in your data set.
Yeah.
And I think you can help expose that bias, right?
Yeah.
And can you also get some information about how to solve this bias issue with your explanation? Can you talk a little bit about that?
Yeah. So first of all, this is bias in your data. So you can of course do some sanity checking with explainability methods that I just showed you. So in this case, in the cases that I showed you, there wasn't any like doubtful variables that are going to be returned. So if there was like sex and race was going to be returned to me, I know that I should pay attention to why the model is using these kind of variables. So and maybe that's more related to fairness, but you also have to take into account that your explainer can be biased as well. So it's quite interesting. So I would encourage you not to use explainability for troubleshooting.
Okay.
So, but you can use it finally to check predictions that are being made. But troubleshooting is quite tricky. So I think
quite tricky. Okay.
for that case, it's better to so explainability can also has a clear link also to, for example, drift. So of course the world around you is changing, and if a model is really a snapshot of a certain point in time, And actually drift is maybe a different topic, but it's closely related, where you can of course compare the distributions. It's more of a statistical problem, the distributions of the set of the real world data that's flowing in, maybe using your streaming data, and then compare that to the data sets that you have trained. So in that case you can detect drift, for example, using statistical tests in order to say something about whether or not you're making predictions that are based on a situation in the past. Yeah.
Got it. Thank you very much for your talk. And with that, we've also come to the end of this meetup. I would all invite you to like and subscribe our page, of course, which should be mentioned in any YouTube video. We had 2 very exciting startups tonight using a bunch of really interesting technologies. You can of course reach out to them later if you want to learn more. You can also contact me. I can help you get into contact with them if you like. And for now, I wish you all a very pleasant evening and hope to see you again at the next meetup.